So in this sessions of video, we are going to learn about Asus laptops, and here in this screen I open a schematic diagram for the Asus motherboard. The motherboard number is X507 UBR. Okay, so UAR. Okay, so revision 1. Okay, so this is the schematic diagram which I open in the PDF in Acrobat Reader, and this first page is basically uh, shows me the connectivity, like it shows the block diagram. So this is a Kaby Lake processor, that is a 7th generations Intel processor, and here are the rest of the component which is connected to the CPU's DDR4 RAMs, EDP panels, and here is my SIO. The SIO in the schematic diagram, there is a no name of SIO. There the name will be EC or KBC. So here is a mention EC. EC stand for the embedded controller, and that means the SIO. The number is IT8995, which is located on the page number 30. So this is a location of my SIO, and simultaneously I open here a board viewer also with this Flex BV. So this is my board viewer. With the help of board viewer, I can trace out the signal and test point very easily. And if I press a space bar, then the board will be flipped like this. So we'll start reading the schematic diagram, and I'll show you the test point of this particular motherboard if it is dead. Okay, so this is a page number 1. So we'll go to the page number where the DC jack is there, where we connect the adapters. But before that, we'll go to the signal ladder. In this diagram is basically a 102 page. Okay, and the signal ladder, we so scroll down and we'll see where is the signal ladder. The signal ladder is on page number 63. So I'll type here 63, and I come here on the page number 63. So this is called the signal ladders. Okay, the signal ladders mean these are the signal and these are their ladders. So how to follow this steps? So first we have to check this signal is called 3VA underscore EC. So 3V means 3 voltage, A means always, so 3 volt always, underscore EC means embedded controller. So this 3 volt EC is going to the SIO. So first we have to check that. After that, we have to check the EC reset on the SIO, that I already told you that here the SIO is mentioned is the EC, that is embedded controller. So the second step, we have to check 3 volt at the EC reset, and then we have to check DSW, that 3VA DSW, okay, on the SIO. And after that, we have to check 3VA SW. Then these are all the signal, then the RSM RST, then the AC present, like that. So these are the flow we have to follow, and then the finally step number 8, there we have to check the power button. Okay, so the power button is there, so we have to check that power button, and then the reflection of the power button is the PM power button. So 303 variation. So here is a, we press a power button, there's a falling edge, and as soon as we press the button, the immediately the PM power button signal will be reflected and the PM power button signal will be out. So that we have to check, and then we have to check SLP3 SLP4. Here is a no SLP3 SLP4. The SLP3 SLP4 is the alternate name is SUSB and SUSC. So step number 11 and step number 13, we have to check SUSC and SUSB signal on the SIO, which generated by the CPU. Okay, after you receive the power button signal. So we'll start from the DC jack. So we'll come on the page number 39 where we have the adapter jack. Page number 39. So this is my adapter jack. So when I connect my adapters, that 19 volt pass through here, then pass this coil, then come across here, and the name of the signal is called AD underscore dock underscore in. So what I'm going to do is I'm going to copy this signal, then I will paste here, and then I'll press a next, next. So when I press a next, then my page is shifted to the page number 54. So I come here, the page number 54, where my adapter input and battery charging section is there. So this AD underscore dock in signal is come across this MOSFET. The MOSFET location is a PQ8901, and MOSFET number is a QM3056. This is a N channel MOSFET. So here the both are the N channel MOSFET, MOSFET number 1 and MOSFET number 2. So here we are in this page, it's called battery charging section. So I'll zoom out and I'll go to this chip. So here this chips, battery charging chips, adapter inputs and battery charging chips. The location of the chip is PU8901, and the chip number is SN2867RUYR. Okay, and the power input to this chip is where it goes the power. So we'll see where it goes power to these chips. First, the chips require the power. So we'll find where the power is. So it is jack, then yeah, this is my power page, pin number 28. It's mentioned here VCC. So here I get a power, that is adapter input power. So first we have to check power on the page number 28. Then after this chip will detect the adapter voltage present. Adapter voltage present is called the AC in or AC detect. That is AC detects means adapter current detect, and there we'll to check a voltage somewhere around from 2.4 volt to 3 volt. So my AC detect pin is pin number 7. So here I have to check the voltage, AC detect voltage, and then the AC OK signal. Okay, the AC OK signal, and this AC OK signal is going to the again output. Now the next is, so once AC detect signal is okay, then this chip will drive one output signal is called the AC drive signal, that is adapter current drive signal on the page number pin number 5, which will drive this MOSFET, it will drive this MOSFET, and here the voltage should generate around 18, 19, 20, 21 like that, so that this adapter voltage will pass this MOSFET, come across here, and then this voltage will pass this output and come across this current sensing resistor. So here is my current sensing resistor. The location is called a PR8938. So here we have to check this voltage. Now the thing is, where will find this resistor? The location number is PR8938. Okay, so the current sensing resistor, the location is PR, what is location is PR8938, right? So we have to come at board viewer. So here is my board viewer, and I have to press control then F. So as soon as I press a control and F, then here I have to type uh, either the signal number or the chip number or whatever, the register number or whatever is there. So I want to find my register, and the register number is a PR8938. So this is my register number PR8938. Okay, so this is my current sensing resistor. So I have to select it and then click on search. So as soon as I press search, then it will locate me that a particular resistor is here. So I have to zoom like this, zoom like this, zoom like this, and here is my resistors. So this is my resistor. Here's a yellow, this point. Okay, so this is my resistor. So here we have to check this voltage. So here's my for second MOSFET, that 8902. This is my 8902, that second MOSFET. 8902, and here we have to check the adapter voltage output, and then at pin number 2 this voltage is going to the different buck converter. So basically the current sensor registered is the output is like a distributor which supply the voltage to the entire buck converter of the motherboard. Okay, so here we have to check output voltage, that is adapter voltage here. If the adapter voltage is not coming here, then there is a something problem, so we have to go back and we have to check this chip, we have to check the supply, we have to check AC detect, we have to check AC OK signal, then the AC drive signal. If inputs, all the inputs are coming but the outputs is not coming, then the chip is faulty. If the inputs and output both are coming properly, and here we are getting 18 or 19 volt at the gate of this both MOSFET, but still here the 19 volt which is not passing to the from drain to source, that then the MOSFET is bad. Okay, so in this way we have to press out. So after battery charging section, then the next things, next steps, we have to go to the 3 volt and 5 volt section. So my 3 volt is and 5 volt section is the page number 53. So here is my 3 volt and 5 volt section. So you can see on the bottom of this page 53, here's a mention that Asus. So this is a model X507 UBR, and below that title is mentioned plus 3VA underscore DSW and 5 volt SUS. DSW, deep sleep wake up voltage. So 3 volt and 5 volt section is here, and here is my chip. So I will zoom this chips and I will see what is the chip number. So this is my chip, and the location of the chip is PU8701. So this is the location, and the chip number is RT8249C. Okay, so this is the location of the chip. Now every chips require a power, and here we have to find the volt in pin, that is called a V in pin, where my adapter voltage entered into these chips. So we'll see where is that. Here. So pin number 12. So these are the pin number, right? And this pin number 12 is called the voltage input pin, and my that voltage come across that current sensing register, and that voltage will come here on the page pin number 12 on the PU870. So here we have to check input voltage, that 19 voltage which entered into the chips. Okay, pin number 12. And after that, this chip will generate the two linear voltage which is called LDO03 and LDO05. So here is pin number 3 is a LDO03, and where is the LDO05? Yes, here is LDO05, which is on the pin number 13. So pin number 13 we have to check 5 volt, and pin number 3 we have to check 3 volt. And if this voltage is missing or if it's coming less, then we have to replace this chip RT8249C. So pin number 3 we have to check 3 volt here, and if this 3 volt is coming here, that means the chip is okay. And after that this chip will get the enable signal. So here's the enable signal, and after that this both voltage will be generated. That is called plus 3VA underscore DSW. Okay, so this always voltage will be generated. So that this also we have to check. So first we have to check linear voltage, that is on pin number 3, and after enable signal this chip will generate this 3 volt output. This voltage you can check across this capacitor, and you can check output of this coil PL8701, that is 3.3 volt, which is called the always voltage. Now our always voltage is generate, and this always voltage is going to the SIO. So we have to shift our diagram to the SIO. So we'll come across, and the SIO is on page number 23. Now the thing is, if you want to find this this 3 volt and 5 volt chip on the board viewer, simply what you can do is you can type PU8701. So I'll come first on the board viewer. We'll see first board viewer where is this chips and where are those test point. Okay, so the chip location is what? So PU8701, right? So we'll come on the board viewer, we'll zoom out this, click here, press Ctrl F, type here PU8701, right? Then select this and search it. So as soon as I press search, then here it will show me the location. So this location toward the CPU side. Okay, so these are the RAM slot and here is the CPU. So my chip is located somewhere here. So I will zoom, I will zoom like this, and then I will click. So as soon as I click here, this chip is here and the pin number 1 is here. So this is a pin number 1, and the chip description, the pin description of the chip is given here. Everything is here given here, the chip's location and everything is given here. The location is a PU8701, and we have to check where the inputs and outputs. So we have to check pin number 12, that is the input, and pin number 3, pin number 12. So here we have to check input voltage, and pin number 3 is our output voltage. So this here we have to check 3-volt output. Suppose so the chip is very small, very tiny. So if you can't check on this pin, then you can check here also on this. These are the PSL 8704 or PC 8702. PC stand for the capacitor and PL stand for the coil. So you can check the linear voltage, that is called the LDO03 voltage, at this capacitor or the coil, and if you are getting a 3 volt here, then the chip is okay, and then you have to check the enable signal, right? And like that you can use this board viewer and check all the signal. So now if my 3 volt is coming, then after that we have to switch to the SIO. So we have to find where is my SIO. So I'll flip the motherboards and I will see where is my SIO. So I'll go to the schematic diagram, and my SIO is a page number 23. So here I type page number 23. So here is my SIO. The SIO's location is a U3001, and the chip number is called IT8995. So this is the IT SIO. Okay, and now we have to check all the input criteria to SIO work. So any laptops, SIO needs first the power, then he need the EC reset, then he need the LID signal, then he need the AC in signal, like that. And after that, once we press the power button, then he generate the PM power button, like that. So we'll see where this 3 volt is coming. So normally this 3 volt is coming on the top side. So we'll scroll the display diagram, and we'll come here, and we can see here. So this is the pin number 2650, 92, 114, 121. These are the supply pins called the V standby. That means V standby means voltage standby. So here we have to check a 3 volt, which is coming from the 3 volt and 5 volt section. So this is my first step here. Here I have to check 3 volt. Okay. After that, once I check the 3 volt here, then the second important step is EC reset. So EC reset will find EC reset. So here pin number 14 is called the EC reset. So this is a EC reset on pin number 14. EC reset is a basically reset the SIO, and there is the RC circuit. R means the resistor and C means the capacitor. So resistor and capacitor is connected into series and given to the 3 volt at the resistor, and across that resistor and capacitor there is one output point, and that output point goes to the chips, and that point is called EC reset signal, which generate a little bit delay signal, that is 10 millivolt delay signal. So here at pin number 14 we have to check 3 volt, that is called the EC reset. And then next step is we have to check lead switch. We'll see whether it is the lead is there. So you can type LID. Yes, LID. So this is a pin number 109. Here we have to check 3 volt, this LID switch, and if it is a 0, then your laptop is not going to turn on. So you have to go back and press that lead sensor. There is a problem, that sensor may be short. So you have to replace that sensor. So here you have to check the 3 volt at LID switch. And the next signal is called the adapter current in, that is the AC in signal. So this signal we have to check on pin number 108 called AC in signal. You can see this signal, this AC in signal, okay, pin number 108. So this is the input signal which is coming from the battery charging section. So see, if the arrow is toward the SIO, means this is the input signal to the SIO, and arrow is output from the SIO, that means the output signal from the SIO. And if the arrow is a bidirectional, that means the signal is both the directions, like that. So after checking lead switch 3 volt and AC in signal 3 volt, and my laptop is now ready for press the power button. So we have to find power button signal. So we'll scroll the our SIO page and we'll see where is the power button signal mentioned. So here is a power switch. Here is a power switch. Okay, the power switch information is coming from page number 31, 32 and 59, and this signal is going to the pin number 110, pin number 110. Okay, so here we have to check 3 volt, and once we press that power button, this 3 volt goes to 0, and when we release that button, is come back to 3 volt. So here at pin number 110 we'll get 303 variations, that is my input power button, that actual power button which I press. And this power button, normally the Asus power button is normally there in the keyboard connectors. So here we have to check that 303 variation, and after pressing the keyboard, the power button 303 variation is not coming here, that means my keyboard is a faulty. So we have to replace the keyboard, like that. After pressing this 303 variation, then the SIO generate the output signal. It's called the PM power button. So the next signal we have to check the PM power button. So we have to see here, where is that PM power button? Okay, we got, see here, this PM power button, pin number 56. Okay, so this is the output signal. You can see here, PM power button. Okay, so pin number 56. Okay, so here we have to check 303 variation after pressing input power button. See, this is the input power button which normally we press, user press, and this is the output power button which generated by the SIO and given to the CPU. So here also we get a 303 variation. Okay, so we'll go into the board viewer and we'll see where is this signal. Press Ctrl F, then PM underscore PWR button, like this. Select the signal, click the search, and then the signal is here. The signal is here. So here we can check the signal at this test point, and here also we can check. This signal is basically is going to the CPU, but we can't check the signal directly to CPU because the CPU is a VGA chip. So we can check the signal at this SL2518 point. So here we can check the 303 variation, that is a power button signal, and this signal generated by the SIO. So here is the opposite side, my SIO. The location of the SIO is U3001, and this pin generate the output signal pin number 56, and you can check the signal here also. Here is with one resistor is called R3019. There you connect a multimeter. See, there is a 3 volt. As soon as user press the power button, this voltage should go to down to the 0 volt and it come back to 3 volt. And if this variation is there, that means your SI is working perfectly, and if this variation is not there, means your SI is bad. So you have to replace the SI. But this SI is normally programmable SI, but before replacing the SI, you have to flash the EC bias and you have to verify it. After flashing the EC bias, still the PM power button output signal is not coming, and then in that case we have to replace the SIO. Okay, so after this PM power button signal generated by the SIO and given to the CPU, that the user press the power button, now the time to respond by the CPU, and CPU generate two signals called SLP underscore S3 and SLP underscore S4. So these two signal is generated by the CPU. But before that, CPU should get a 3.3 volt. It's called a VCC DSW. There is a 3.3 volt which coming from the 3.3 volt buck converter. The another important signal CPU need to turn on, and that section is called the RTC section. That is the RTC VCC, that is a 3 volt, RTC reset, that is a 3 volt, and there is a one crystal 32.7 kilowatt crystal that has to be turned on, which generate a 32.7 kilowatts clock. So the RTC section must okay before to turn on the laptop. Okay, so now the CPU get first VCC DSW, that is a 3.3 volt, RTC section, and DPWR, okay, signal. So CPU is now ready. So now once CPU get the enable signal from the SIO, that is the PM power button, then he has to respond as to generate the SLP3 SLP4 signal to the SIO. SLP3 SLP4 signal on initial stage is a 0 volt, but after pressing the power button, when CPU respond, and then CPU convert this 0 volt into the 3 volt. So we'll find where are those two signal, SLPS3 and SLPS4 signal. So here we can't find this two signal, SLPS3 and SLPS4. The alternate name of the SLPS3 and SLPS4 signal is called SUSB and SUSC. So you can see here pin number 57 is called PM underscore SUSC, which is coming from page number 25, and 80 is connected to the 86. So in page number 25 there is a CPU which generates this signal PM underscore SUSC, and which is going to the pin number 57, and here we should get a 3 volt. So you can connect the multimeter on pin number 57. You have to check 3 volt here, and we'll find where is my SUSB. Yes, SUSB is page pin number SUSB. Yeah, this is SUSB. Yeah, you can see SUSB coming from page number 25, PM, that means the post SUSB, and which is going to the pin number 35, right? 35. So here we have to check both the signal which is generated by the CPU. Now we'll go to the board viewer and see where we can check easily of this signal. So come to the board viewer, press zoom out, press Ctrl F, type PM underscore SUS. You can select any of the signal, SUSB or SUSC. Select the signal, click on the search, and here are the signals. So you can see here's my SIO. So this SUSB signal is coming pin number 35 on the SIO. So you can check here on the pin number 35, or you can check here also this signal, SUSB signal, which generated by the CPU, and here you should get a 3 volt, and if the 3 volt is not coming here, then your CPU is a bad, CPU is suspected. But before CPU is suspected, first you have to make sure CPU should get the power, that is called VCC DSW, which voltage is coming from the 3 volt 3.3 volt buck converter. It's called the always voltage. CPU RTC section must be okay, and CPU should get DPWR okay signal from the SI. So these are the input criteria need to CPU turn on, and once you press the power button, CPU must generate this SUSB and SUS signal, and if these signals are not coming, then CPU is bad. So you have to conclude the CPU as too bad and CPU need to replace. So friend, in this way we can diagnose the Asus motherboard. So I explain you this motherboard with the help of the schematic concept as well as with the using the board viewer, and simply you have to follow all the steps to diagnose if the motherboard is not powering on. Okay, so thank you very much.